John Kokajko, are there any black holes with a dark matter accretion disk? When you ask what is a black hole made of, people always wonder, like, what would happen if you had a matter black hole meet an antimatter black hole? Would the black hole cancel out? And the truth is that there's, like, for a black hole's perspective, there is no difference. That if you had a black hole made of matter, that's just a black hole. If you had a black hole made of antimatter, that's also just a black hole. And the way you can kind of think about it is that if you took a regular black hole and an antimatter black hole, or even just like a regular planet and an antimatter planet, and you mash them together, you would get pure energy, gamma radiation. Well, gamma radiation goes into a black hole and it just turns into more black hole. And so, we know that energy, matter, all of that turns into more black hole. Even gravitational waves turn into more black hole. If they happen to cross the event horizon, then they just join the black hole. And so what happens to dark matter? Now, we don't know what dark matter is yet. And so if dark matter is an error in the calculations, well, then it can't go into a black hole. If dark matter is, we didn't understand gravity at the larger scales, then it's not a thing that goes into a black hole. But if dark matter is some kind of particle, then once it goes into the black hole, it becomes part of the black hole. Now, your specific question was, will a black hole get a dark matter accretion disk around it? And this is where we want to sort of look at one of the sort of interesting features of dark matter that seems to be showing up out of all of the observations that astronomers have made so far. And that is that whatever dark matter is, it doesn't seem like, if some kind of particle, that particle doesn't seem to have a cross section or a very large cross section. So what is cross section, right? Cross section is really the size of the particle. How likely are the particles to bonk into each other? And so the classic example of this is the bullet cluster, where you had these two galaxy clusters colliding with each other. And when astronomers used gravitational lensing to look at the bullet cluster, they saw that the stars had just passed right by each other. And that's because stars, relative to each other and relative to the size of the sort of larger area, have no cross-section, right? They're tiny little things, just a million kilometers across in spaces that are 4 light years across. Like, the chances are quadrillions of kilometers across. Like, the chances of them colliding, very, very low. And so when you get two galaxies flying into each other, the stars don't collide. And so the stars will then come out the other side. But the gas is ever present. The gas has fairly large cross-section. And so what you see is that in the bullet cluster and in other examples of galaxy collisions, you get the gas piling up in between where the galaxies collided with each other. And you can detect this through the mass of you can detect this by seeing the glowing radiation of all of the gas that is piled up in the middle of where the galaxies collided. But the last piece is, what about the dark matter? And so if dark matter has a large cross-section, then you would expect it to pile up in the same place that the gas does from the galaxies. And instead, the gravitational lensing, the distortion of the gravity, tells you that the dark matter went with the stars, that it doesn't have a cross-section. The dark matter passed through itself and the gas and the stars and didn't collide, and is still in a halo around the stars. And so let's bring this back to a black hole, right? A black hole gets this accretion disk, and the accretion disk partly comes from the fact that you've got all of these particles with a cross-section that are bouncing into each other, and they are getting tied up around the outside of the black hole. Think about when you pull the drain on your bathtub, and all of the water can't flow down into the bathtub drain quickly enough, and so you get this rotating, swirling liquid. If water had no cross-section, then it could fit an infinite amount of water in the bathtub drain, and it would all just go out immediately. Your bathtub would just instantly empty out. And so, does dark matter form into a accretion disk? Probably not. That you're not going to get, there's probably some, like, it probably has some cross-section, not no cross-section. So there would still be a halo or an accretion disk of dark matter, but probably a fraction of what you would get if that stuff was just regular matter. And so, it just goes back to the fact that we, We don't know what dark matter is, but there is this series of observations that sketches out the large scale structure, the terrain of whatever the answer is. It has to live in this area, about in terms of its cross section, on how it interacts with regular matter or itself, on how it generates gravity, you know, the temperature, whether it's hot or cold, whether it's fast moving or slow. These are all things that have been already bounded and constrained for what dark matter must be. We're still waiting for the what is the answer, but you know, nature has no responsibility to give that stuff to us so easily. Okay, I'm back. Thanks, everyone. Now, I gotta warn you, I was outside of the country for 2 weeks, and I got off the plane and was hit by a wall of histamines in sort of perfect Vancouver Island spring. Everything is producing pollen, and the allergies just came on hard. So I've got a Claritin in the system. I am vastly less gloopy than I was earlier today and earlier this morning, but still, you're going to hear it in my voice, you're going to hear it in my nose, and I'm going to make more dad noises than I normally do, and I just apologize for those of you who just like can't tough it out. You're going to watch the edited version. Chad will nicely edit out all of that stuff, and so it'll seem as if I didn't sniff or drink water or cough once. But if you're here for the 2-hour live stream, you're just going to have to tough this out with me. Japan was great, as always. Yeah, what an amazing country. This was like Japan the sequel. About 2 years ago, I took my son to Japan. This had been his graduation treat. This was, what's the one place in the world you really want to go to? And he's like, I really want to go see Japan. So we organized the trip. And in fact, we had originally organized a trip back when COVID hit. And so we had to cancel the first trip, and then we were able to finally do the trip in 2024. And it was great. We had a wonderful time. He's a great traveling companion, and it blew his mind, it blew my mind. And I came back and I was just raving about Japan to my wife and to you. Like you, I know I won't shut up about the place, but and my wife was like, okay, well, put up or shut up, let's go. And so we were able to go to Japan for the last 2 weeks. And I was very nervous about it because my wife does not enjoy humanity. Likes animals, not a fan of people. And Tokyo, where we started, is 37 million people. It is the most populated city on Earth. There was no shortage of people, but she absolutely loved that everybody just actively ignores you. And so you just move through the city like a ghost. Nobody is looking you in the eye. Nobody is trying to interact with you. She thought that was just terrific. For me, I'm very gregarious, very outgoing. I'm the one trying to make connections with people around me. And so, but for her, she thought it was great. She loved the food, which was sort of, she's vegan. So, they put various fish products into almost every food they make there. So that was a little tricky, but we found some great vegan restaurants in all of the cities that we went to. The sites, the shrines, the trains, all of that was just terrific. So I can still thumbs up Japan, and I guarantee this is not the last time I will be going back. Although next time I want to do some work. I want to go to JAXA. I would love to watch an H3 rocket launch. I would love to chat about the Phobos mission. So stay tuned for that. Hopefully next time I go to Japan, I'm going to get some actual work done and bring you back stories and interesting interviews. But apart from that, I'm back up to speed. I hope you were able to tough through all of the overtime episodes that we launched out on the platform while I was gone. That's all done. This is the live stream. Now, for those of you who aren't aware, I go on hiatus for summer, so July and August. So I don't do live streams during July and August. So we run overtime episodes during the summer. I still do interviews and I still do space bites, but I don't do astronomy cast and I don't do these live streams that you're watching right now. And that is just the pressure to go and get myself to a high-speed internet connection every Monday is rough, and I need like a little bit of a break to work on the garden, get to know the chainsaw, and cut down trees and so on. So there's going to be three more after this. So there'll be 4 total live streams until the end of June, and then we'll be back at the beginning of September. But you won't even notice. And who knows? Like I never know what kinds of crazy shenanigans. Like partly doing the summer hiatus is that it just gives me time to work on other projects, things that require a little more cognitive load, thought process, and so on. And Anton, not that Anton, but my editor and producer, has got a million ideas, and so this gives us a chance to work on a lot of those ideas. So we are going to get into this week's question show, where you're going to hit me with your questions. I am going to respond with my answers. The thing to keep in mind is that, I've got my 3 rules. So the first one is to remind you that I am a journalist, not a scientist. And so if you want to get my proper scientific understanding, my opinion of some scientific theory, I cannot give it to you. I have no opinions. I am merely a conduit for the scientific consensus. And that statement drives a lot of people crazy, and that's fine with me. Be driven mad. The second thing is I try to give emphasis to the people who've never had a question answered before. So if that's you, I like your chances. Go ahead, take a risk. Ask me a question. I love it. And then the last thing is, of course, there's a lot of reasons why I might not answer your question. I don't know the answer. I've answered this question so many times in the past that I know my audience is going to get kind of bored of it. It's going to require too much math. Or I just don't have time. But don't ask the question a bunch of times. Just go ahead, put your question into the YouTube comments, and I've got a database that slurps them out and puts them in front of me, and so then I can look through them and showcase them and highlight them and answer your questions. I hope I remember how to do this job. Having not done it for 2 weeks, I think I'll be okay. All right. Jimmy James, how glad are you to have been on vacation for that sewer break? Wow, that's a deep cut. So in the Comox Valley, where I live on Vancouver Island, about a day before I came back, the sewer system broke in our city. And so we've got about 50,000 homes connected up, and the system wasn't working. And so there were signs everywhere saying, like, don't flush your toilet. Don't have a shower, because all of this raw sewage was just overflowing from the system and going straight out into the ocean. And there's just some awful videos of just raw sewage coming out of the system going straight into the ocean. And I think it was like 6 million liters of raw sewage were let out into the ocean before they were able to get the system repaired. So that was lovely, and we missed it, but it wouldn't be an issue for me anyway, because I have my own septic field on our property. So I am not connected to the city water, and I'm not connected to the city sewer system. I'm too far away. I would if I could, but I'm too far away. And so I have to have my own well and my own septic field. But yeah, nasty. So yeah, it was kind of, I'm glad they got it resolved, but you just, you realize how we are just one bad day away from dystopian barbarism, right? Just one broken sewer, and it's just man's inhumanity to man. Kim Barron, what books are people reading? The newest Dungeon Crawler Carl is just out, but what else are you reading? So I would love to hear in the chat what you guys are reading. I'm reading right now Children of Dune, which is the 3rd book in the Dune series, and it's crazy, like Dune Messiah was. Dune, the best science fiction book ever written in my mind. It's the perfect book. Dune Messiah, short, kind of weird. Children of Dune, longer, but also weird. And then from what I understand, the next 3 books just get even weirder. And I'm going to read them because I feel like I owe Frank Herbert that energy for writing Dune, but I understand that I may not like them, and that's just going to be what I'll have to deal with. But yeah, let us know what you're reading. And I can't wait to read the new Dungeon Crawler Carl. I've put myself on hold for the library for that book, and so as soon as it comes in, I will read it. If you haven't read the Dungeon Crawler Carl books, they're so good. Like, they are popcorn. They are absolutely not deep literature that's going to make you question your, existential crisis, but you are going to really be entertained for the duration of reading that book. Those books. Nicola P. Byte. Is 2028 still a realistic target after the last Starship flight and the New Glenn explosion? So we're in a funny limbo state right now, but it feels like we're always in these kinds of limbo states, but we are in another limbo state right now where we don't really know what the future holds for human space exploration. And previously, it was because we didn't know what was going to happen to the Space Launch System. We didn't know if Starship was going to be able to deliver, when that was going to be able to deliver. There were no other, what's going to happen with Starliner? Was it going to be able to deliver humans to the space station? Like, things were just in flux. And so now we live in this other state of flux where Space Launch System has definitely been able to deliver astronauts to space, took them around the far side of the moon, but it is a ludicrously expensive rocket. It costs $4.1 billion per launch, and Congress is going to run out of appetite to light money on fire at that rate to see more of those space launch systems fly. It is the old school rocketry way. And so you've got New Space. We've got SpaceX. And SpaceX... I told you this was going to happen. Okay. So we've got SpaceX, and SpaceX has been taking us through all of the tests with Starship. I think we've gone through 10 flights so far with Starship, and we saw the V1, we saw the V2, and there was a bunch of issues. And then just last week, we got V3. And, there were a lot of problems with that launch. The engines on the Super Heavy booster cut out prematurely, and that caused it to tumble and crash into the ocean. That was not the plan. The plan was for it to recover and land gently. Like, this is the first time they've done the V3 Super Heavy. It would be nice to have that thing work. But the first time you ever use one of these rockets, it's not going to work the way you want. And then Starship failed to keep all of its engines ignited all the way up into orbit, but it had a failsafe and was able to handle that. And then it was able to deploy a bunch of dummy satellites and see a selfie of itself. And then it was able to re-enter the atmosphere and land relatively safely and explode in the ocean, but in a controlled manner. So some of the things weren't completed as planned. Other parts were completed. And so really with SpaceX, it just comes down to the cadence. Was this we've got to fix these problems and it's going to take us another 6 months to get there? Or is this, I know what the problem was. It's computer software code. We should have this fixed, and then we're going to do some more tests. But really, we're not going to know we're on our way to seeing progress until a couple of things happen. One is that we see the reusability of Starship. Like right now, they've ditched 10 Starships after the launch. We need to see these things return to the launch, go into orbit, return to the launch pad, get caught safely by Maxilla, by the chopsticks. That is not actually totally mission critical. That if SpaceX wants, they could just make disposable Starships. It's going to be more expensive than what they were originally planning, but if they have to, they can make disposable Starships and not catch them, just let them burn up or let them crash into the ocean, or use them as tests and see what happens, or just leave them in space. But the real issue is, can they demonstrate transferring propellant in orbit? And can they get the human launch system ready for Artemis 3, which is due next year? I mean, we are a year away from the from the test of Artemis 3. And there's no great indication that this is going to be a gigantic problem. I mean, it feels like the issues that happened with V3 are solvable. I mean, the fact that rocket took off, the Starship went to space, like these are solvable problems. And so we'll find out how quickly they're going to do their ongoing cadence of this. And it would be great to see them be able to get to a place where they're able to demonstrate the docking capability, fuel transfer capability, and then that gives us a nice runway to get to Artemis 4. Blue Origin is another story. That explosion on the launch pad that we saw last week was catastrophic. We lost, or they lost, or damaged, heavily damaged, like they lost a rocket. They terribly damaged all of the facilities that are around the rocket at the launch pad. You're looking at the launch gantry, you're looking at the transporter, you're looking at other hardware, refueling, the deluge system. All the stuff was around and deployed and all took some level of damage. And you can imagine, if this rocket exploded and all this debris went, all this, you're not going to go, yeah, I'm sure it's fine, right? Like I'm sure that deluge system is fine. No, you're going to need to go and examine it very carefully and swap out any parts that took damage and get yourself back to a place where you are operational. And they have to figure out why the problem happened, and they have to prove to the government and the regulators that that problem isn't going to happen again. And so that means they're going to have to redesign the rocket. They're going to have to do more tests, more wet dress rehearsals, more test firings of the rocket. And it looks like the explosion started down in the engine area of the New Glenn. And so was it a problem with these rockets, the BE-3 rocket? Was it a problem with the engines? The BE-4s or the BE-3s? Someone in the comments can tell me. I forget. And so this is a problem, if this is a problem with the engine, this problem is going to affect other companies that are using the Blue Origin's engines. Specifically, you've got United Launch Alliance with the Vulcan rocket. That's using Blue Origin engines as well. And so then this is going to kind of cascade. And Blue Origin is on a tight timeline. They were able to worm their way back into the government's good graces and be potentially a serious competitor to be able to provide landers to the surface of the moon. Now their rocket blew up. This is a problem. So your question, which I am now forgetting, but I'm going to go back, is 2028 still a realistic target after the last Starship flight and the New Glenn explosion? So we have no idea. Like, we just have no idea. And I think, if you go back to the very beginning of when Elon Musk announced the interplanetary transport ship, when you go to when Donald Trump announced the Artemis program to carry humans to the moon by 2024, when you go to all of the various announcements that were made, things have slipped, and here we are. And I think the unspoken concern that is the through line from this is the U.S. going to put humans on the moon before the Chinese do it in 2030? Now, obviously, the Americans have already done this. There is no race to the moon. The Americans have already won the race, but I think there is a certain amount of national pride to try and get back there before the Chinese demonstrate. And maybe that the Chinese will have a more sustainable, ongoing, continued presence on the moon, while the U.S. might be going down this route of a $4.1 billion per launch space launch system. It's just going to be too expensive, and they're just going to go forget it, right? Because going to the moon costs a lot of money. It costs all the monies. And you've got to be serious that this is a thing that you want to do, and you've got to have this long-term commitment, and you've got to be able to fund into the various technologies that are going to take you back there. And if you take your eye off the ball, if you let budgets creep down, if you let pressure make engineers retire early, the thing will come off the rails in 1,000 different little ways. And then we'll be 2035 and someone will say, were the Americans going to go to the moon at some point? So I've been watching the conversations that Jared Isaacman has been having, and so far I'm actually really impressed. He has provided a level of focus on the kinds of priorities that I think match what people in the space exploration community would like. I think, there was a lot of damage that was done to NASA and with sort of before he came on board, and especially when it comes with science programs, Congress and the Senate have been able to block that. And so we haven't seen the really deep mission cuts that had been requested by the White House administration. But now hopefully we're going to see some kind of leadership that is not just going to preside. Now we're going to see some kind of leadership. It's not just going to preside over cuts that aren't as bad and a workforce that is feeling unappreciated, that we're actually going to see some kind of vision and some kind of encouragement and a return to the scientific greatness that NASA has exemplified throughout its history, right? And I'm like, I don't know. I haven't had this conversation with people at NASA, but if I was somebody at NASA, especially someone late in their career, I would be feeling pretty unappreciated at this point. And it's really hard to get an audacious goal completed with a workforce that is feeling a little down. So we will see. I think 2028 is ambitious. I would not be surprised if that slips. And it feels like it's starting to move towards it's going to be a squeaker. But we'll keep you posted. We'll watch every twist and turn of this. Ragetail 3. Is NASA progressively looking into solar sail technology? Absolutely. They have recently launched a solar sail. I forget what the acronym stands for. It's ACES. But it was a solar sail that they were demonstrating. They had another solar sail, the NEA Scout, that they had put on the Artemis 1 mission, and that was going to be a solar sail that was going to take it to an asteroid. Unfortunately, that one failed. They've got other solar sails in development right now, and there's like a real hardcore group of engineers that are really proposing solar sails. We see suggestions for putting solar sails on various missions. Even back when the Deep Space Gateway was being developed, one of the ideas for station keeping was to put a solar sail on the Deep Space Gateway as a way to save propellant. So NASA is very familiar with the technology. They've done a lot of the development of this technology, and upcoming missions will probably take advantage of this. But they're not the only ones. The Japanese Space Agency had their Ikonos mission a couple of years ago. The Planetary Society funded the LightSail 2 mission. And so we've got enough data points to show that solar sails will work in some situations and can provide some benefits. Some of the coolest ideas, like, for example, trying to send a mission out to the solar gravitational lens, may just absolutely require a solar sail. There's no way to get out there except you dive down very close to the sun. You then do a quick gravitational slingshot around the sun, gathering as many photons as you can while you're super close, and then you use that to speed your way out to the solar gravitational lens in a reasonable amount of time. So, I am constantly, at Universe Today, we are constantly reporting on new solar sail ideas and technology. And perhaps that's just because it's something that I'm so excited about that I'm always recommending it to the team. But still, we are definitely seeing a lot more development into solar sail. It's funny, there was the Breakthrough Starship Foundation that announced the $100 million several years ago, and then it has come to light that they never really paid out very much money, and that a lot of people have been just continuing to develop the underlying technology for light sails, solar sails, powerful space-based lasers, communication arrays, all of the bits and pieces of all the bits and pieces of an interstellar mission on their own. And there is funding. There's through NASA's NIAC grant. There's National Science Foundation in Canada. There is just like in different countries, there's different pots of money that is being directed towards these ideas. Crystals, light sails made of crystals, like a lot of really cool ideas and ones that I've reported on and so on. So I think you're seeing a lot of flowers blooming right now that will pay off into actual tested technology in the coming decades. And I don't think we need to just rely on NASA. There's a lot of people that are working on this, and we'll get there from many different pathways. But I think it's such a good idea that it just won't go away. Matthew 1979, Anton Petrov said that little red dots were brown dwarfs in our own galaxy. Is that true? I haven't seen that. I haven't seen his video, and I haven't read the paper, so I cannot tell you. I would have to. Whoops. Yeah, I would have to watch it. I can sort of imagine the chain of events that you're getting that, because little red dots are infrared signals, and James Webb is able to detect the infrared, but you would be able to measure the redshift of the object and know that it is seen early on at the beginning of the universe and not something that is just a few light years away. Like, you would be able to tell the difference of that. So I would have to sort of see. I apologize. Floater 81 floats. Will it ever make sense to mine asteroids for materials that will be used on Earth, even if it is possible to safely deorbit large chunks of asteroid? It will probably never make sense to mine asteroids to bring back the stuff back to Earth. That the costs of sending a mission into space to go to an asteroid, the amount of hardware that's going to be required, the propellant, it's going to cost you billions of dollars. And the classic joke, the quote, the thing that we always talk about is that if there were, like, what's the most expensive thing that you could find on an asteroid? You could find iridium, you could find palladium, you could find platinum. Well, if there were bars of iridium just sitting there, nicely mined on the surface of an asteroid, it would be too expensive to pick them up and not worth it. That it's still going to be cheaper to dig a hole in the ground here on Earth and collect the palladium and platinum and iridium and all of that kind of stuff. People talk about how much asteroids are worth. Like, this asteroid is worth $8 quadrillion or something like that, right? Well, the Earth is made of asteroids. The Earth has all of the same stuff that asteroids have in them. Now, the thing that asteroids have is they have those metals in a more concentrated way. The Earth, all of those heavier metals sunk down into the planet. And so they're not as easily accessible as they are on asteroids. But that stuff is in seawater. Like, people are working on technologies to be able to harvest gold and uranium and other heavy elements and platinum and iridium from seawater. And that stuff is just in the ground. And that it will still, for the long future, be cheaper for us to just dig holes in the ground and mine this stuff out than to consider bringing it back from space. That said, where mining asteroids is going to make a ton of sense is when you need that stuff in space. And so you imagine, let's say you're going to build some kind of facility that's going to require iridium or platinum or palladium or even just iron. Well, you could either launch that stuff off of the surface of planet Earth, and you're going to have to pay ludicrous amounts of money. I mean, like, really think about how much it costs. Like, say it costs you $5,000 per kilogram to launch something off of the surface of the Earth into low Earth orbit. If you want to launch something to the surface of the moon, you are looking at millions of dollars per kilogram. Like, there's nothing that is worth millions of dollars per kilogram. Gold, not platinum, iridium, nothing. So there's just no value in that. But once you're in space and you need to add these metals and minerals to your spacecraft, then it actually does make sense that you mine from an asteroid. You then spend just a tiny little bit of propellant to get from your asteroid, because the gravity is very low on the asteroid. You just spend tiny amounts to get to wherever you need this, whether you're building trusses for your giant 100-kilometer across space telescope, and you're pulling those resources from space. So a lot of asteroid mining is not about can we bring this stuff back to Earth. It is about can we make this stuff available to other stuff that's already in space. And I find that idea really exciting, that right now we see space as this, we have to deliver everything from the surface of the Earth, and that is not sustainable. But imagine this future where we've got robots that are mining asteroids, and they are automatically using mass drivers to send material to other locations, and other robots are building things into larger and larger structures. Like, it doesn't feel like that is, well, here's the new mission and it's going to cost you $8 billion and here's how long it's going to take and here's the timeline. It's just the robot factory is out there spinning out new spacecraft chassis or something, and it can produce 3 chassis per year, and the distribution system is working. It's much more like Factorio than it is sort of a giant project management task the way it is today. There is one idea that I kind of like, though, which is, you talk about, like, how could you get this stuff back down to the surface of the Earth? That if you were going to try and drop bricks of palladium through the Earth's atmosphere, well, they would burn up. And so you're going to need some kind of descent capsule. Well, you're going to have to then launch the descent capsule. But there was an idea, and I don't know how valid this is. I heard this from Peter Diamandis, who was the founder of the X Prize. And the gist is that if you spin it into like this giant ball, very, very low density, that it will then slow down as it hits the Earth's atmosphere, and it won't burn up, and then it'll just fall and make its way down to the surface of the Earth, which is pretty cool. So maybe that's the way you have asteroid mining that is spinning out fluff, palladium fluff, into giant fluffy balls and then throwing those at the Earth. Sorry, just looking at the questions. Gadzooks, do you think we might have to wait 5,000 years to send humans to Alpha Centauri when it will be a lot closer? Now, I don't know the exact orbital mechanics of the Sun versus Alpha Centauri as they move around the Milky Way, but all of the stars are moving relative to each other, and that there were times in the past, and not a long time in the past, like say 50,000 years ago, when a star came within 1 light year of the Sun, which is kind of crazy. Like, we would look up and we would see this very, very bright star that was very close to us. And there are times in the past and in the future when stars will come within 1/10 of a light year of us, that it will be by far the most bright, I guess the second brightest star, if you're going to be, really particular about this. But yeah, that the configuration of the stars that we see in the sky are just an example of our current time. You go forward 100,000 years, a couple 100,000 years, and the Big Dipper no longer looks recognizable, which I find a mind-blowing idea already. But so let's think about what it's going to take to be able to go to another planet, like say Alpha Centauri. And, science fiction has filled our heads with the idea that we're just a couple of decades away from us pulling together everybody and putting them on an interstellar mission. The year is 2280 and the mining ship has arrived at Alpha Centauri or whatever. And the reality is that it's just like the amount of energy involved, the technology required to keep humans alive for that kind of a duration is ludicrous and beyond our capabilities. And one of the most interesting papers that I've read on this subject is called the weight calculation. And the gist is that you sort of think about, let's say you send a colony ship to Alpha Centauri, and then 10 years later, the technology is much better. And so now you send a new colony ship to Alpha Centauri, and it passes the first colony ship. And they look through the window, and the people on the first one are very sad because now they left earlier. Now they have a longer trip to get to Alpha Centauri, while the other ship is already on its way and it's going to arrive there earlier. And then 10 years later, you've got new propulsion technology and a new colony ship goes and it passes the first and the second. Well, there is a time that you have to wait where you're not going to pass the other. Like that is like the best strategy is to just wait until the technology has matured to the point that you can reach this other star system. So there is going to be a natural number. There will be a year. If you put in all your estimates and your assumptions, you'll be able to calculate the year when humanity is likely to have the technology to be able to send a colony ship to Alpha Centauri. And I don't know what that number is, right? It could be 500 years from now. It could be 10,000 years from now. It will be some number. So that's sort of like the first thing to kind of keep in your brain. And that the closer the stars are, the less time, the less technology, the sooner we could attempt that various idea. And so one of the really interesting ideas, if you sort of go back to the Fermi paradox, and when Enrico Fermi was looking at the Milky Way and thinking about, the universe is big and it's old and life on Earth formed as soon as it could, and it's feasible. The laws of physics don't prevent us from going to other star systems. Where is everybody? Why that maybe it would take you 10 million years to be able to send a spacecraft to every star system in the entire Milky Way. And yet we don't see the exploring von Neumann probes coming from all of these other civilizations. But recently, there was a paper, David Kipping worked on it, and Adam Frank and some other people said, well, if you consider the close flybys of all of these stars, that instead of you saying, we're just going to brute force, go from this star to the next two stars to the next two stars, instead, if you just wait 10,000 years, 50,000 years, you just wait on average for stars to get extremely close, and then you just leapfrog to the next star, it actually doesn't add very much time to your total exploration time. That the civilization that brute forces and it spends all the money gets the entire galaxy explored, colonized in 10 million years. But the one that waits for all of the close flybys of the stars, it only takes them a couple of extra million years. Like, it is not a lot. And they save 90% of their fuel because they did this in the most efficient way. So there's a lot to be said for looking at the kinematics of the stars in the Milky Way and then timing your expansion, as long as you're patient, right? Timing your expansion to match when all of the pathways are as quick and as low energy as possible. And that still gets you to a fully explored or colonized galaxy in a realistically reasonable amount of time, which makes the Fermi paradox even weirder. That for all the people who say we can never travel to Alpha Centauri, well, and then you say, well, what if Alpha Centauri was a tenth of its distance? What if it was only 0.4 light years? What if it was 0.04 light years away? Could we get there then? And that the longer you're willing to wait, the closer stars will come on average. That's crazy. And yet, that is what's happening out there in the Milky Way. Fermi's proponent, antimatter power first or fusion? I think we're going to see fusion power first. Now, the joke, of course, is that fusion power is always 30 years away. But at this point, we are seeing the development of a large tokamak facility in Europe, the ITER facility, and it is, a decade away from attempting its first fusion. They're going to start with deuterium fusion or tritium fusion, and then they're going to move their way up as they get better and better at the technology. And this is a serious attempt. This is okay, we think we understand the fundamentals of fusion. Let's spend the money to build a giant machine that should be able to create sustained fusion. But you've got other work. The Germans are doing this. The Chinese are doing this. You're seeing better and better fusion that's going on. And so I think we're going to see the synthesis of all of this. And that maybe 30 years from now, somebody will demonstrate sustained fusion that produces more energy than it takes in. And, we saw a couple of years ago the National Ignition Facility in the United States test laser fusion, where they fired a whole bunch of lasers at a little pellet of hydrogen fuel, and they were able to generate more power out of the fuel than they put into it. But that didn't account for all of the lasers that they had to do. And then it was, and I forget the number. They got like they put 2 megajoules in, and they got like 3 megajoules out. But then there was 200 megajoules of lasers that they're having to spend. So that was not cost effective, while these tokamaks may very well get to a place where you're just getting cost effective fusion that is coming out of the facility. And then the market forces will probably work to bring those costs down and make it more efficient and make it more reliable, and so on and so forth. So antimatter is actually not a form of energy generation. Antimatter is really a form of energy storage. That antimatter is the most efficient method of generating energy that we know of. You take matter, you take antimatter, you touch them together, you get pure gamma radiation coming off of that annihilation. And so if you can go and take a giant particle accelerator, generate antimatter, somehow capture it, store it in some location, then when you need a very compact form of energy, you take your antimatter, you just find some local matter, you put them together, tons of energy, you've done that. And the consequences of this, and I think the question you're really asking is, we're going to have fusion rockets, or we're going to have antimatter rockets. And we're still probably going to have fusion rockets before, because we are already seeing some really interesting ideas for fusion rockets, direct fusion rockets, where it's like it's a halfway point between a thermonuclear weapon that is being detonated in some level of control versus an actual controlled fusion reactor that's pumping out electricity, right? Like we're on the spectrum in between those. And this technology is maturing. Some people have made some really interesting advances. I've reported on them. NIAC has been funding various fusion engine concepts. There's a lot of companies that are working on that. If you do search on my channel for fusion rocket, you will probably be able to watch a bunch of interviews. People are working on antimatter storage. CERN recently announced that they had sort of gathered a bunch of antimatter, put it on a truck, moved the truck around the CERN facility, put it back into a different system for doing testing, and they were able to hang on to it. And so antimatter containment is coming along, but it is a battery. Antimatter is not like, let's just harness the antimatter that's everywhere. No, it is, let's use fusion or fission or solar power to generate antimatter, and then let's store it so that we can then use it in a compact form later on. But I think we are absolutely going to see fusion come first, then antimatter. Antimatter is great. Antimatter is the most compact form. It is the probably the system that gets us to the stars. That there's almost like, apart from a light sail, there's really nothing that has the energy density that is required to be able to accelerate a rocket to another star system than antimatter. And so we will need to master it before we can make an attempt to send spacecraft to other star systems. I think laser sails get us probes to do fly-throughs of the star systems. Antimatter rockets give us maneuverability, carrying crew, passengers, colony ships, DNA factories, things like that. Dougal, did you find anything new to become obsessed with during your recent travels? I mean, every time I go to Japan, I get obsessed at varying levels to various things, because it's such a obsession dense country. I've got a ton of pictures on my camera roll of garden features that I saw, interesting ways that people had solved problems for gardens, bonsais, benches, fountains, sand, rock features, things like that. And so I've sort of looked through the list and think like, how can I adapt this to my own property and the kinds of landscaping that I'm looking to do on my land. So that there's a lot of that. And then of course food. There was a bunch of interesting food that we had, and I'm like, can I recreate this? And so I've got sort of a bunch of ideas that I want to try and recreate here at home. But I would say that the thing that I just found really super cool was this concept of it's called gunpla, and these are Gundam robots, like little articulated robots, like think BattleTech, think Robotech, think Gundam, right? Big fighting robots, think Pacific Rim, but they are made without glue. And so you buy the model set, it doesn't cost you very much, maybe 15 to 20 bucks. And then you get really nice clippers that clip away the plastic from the robot. And they come in different colors, all the different colors that you're going to need to put the robot together. So you don't need to paint it. You don't need to prime it. You don't need to do all of that kind of stuff. It just, the robot comes together from all of the parts that they give you. So it's like a 3-dimensional puzzle that you build. And in the end, you get a really cool fighting robot, which is very cool. So I bought a Gunpla, but I'm going to end up giving it to one of my kids as a gift, but it has definitely got me kind of inspired to make a couple of them. So don't be surprised if you see some Gundam robots behind me on the shelf at some point. But it's super weird because it's like, you can see that the technology of these is so advanced. The quality control is so good. The fit is so tight. And yet they just make fighting robots. When you think about all the kinds of things that you could do, like, why does it have to be robots? Why couldn't it be cars? Why couldn't it be airplanes? Why couldn't it be buildings? Why couldn't it be spaceships from science fiction? Why couldn't it be the Enterprise? Like, why is it just fighting robots? So it's very strange to me. And it just shows this sort of local minima, this rabbit holing that goes on in various cultures where they come up with something really cool and then they just make a really obsessive version of it, and yet this would have other applications around the board. And it kind of makes me want back to, man, it'd be great to have a 3D printer. So thanks everyone who has been recommending 3D printers to me. Mad Million, what is your opinion of how NASA handled 3i Atlas? I don't really understand the premise of the question, because NASA is just one. I mean, NASA is an agency that funds the development of telescopes and does some science, but they actually sort of help the funding of other science. But in general, the kinds of science that was applicable for the interstellar object 3i Atlas was telescopes and observatories around the world. So we were reporting on what was happening with 3i Atlas. We were talking about what was coming out of the Subaru telescope from Japan, although it's located in Hawaii. We were talking about the Keck Observatory, the Gemini North and South. We were talking about various space-based telescopes, James Webb, Hubble Space Telescope. And then if you go and like look at one of the papers, say analysis of 3i Atlas from the James Webb Space Telescope, it is going to be some team of astronomers located around the world that has like no affiliation with NASA. It might have an affiliation with NASA. They might have NASA astronomers on the team. But mostly it's going to be, this person works at the University of Texas, this person works at the University of Shanghai, this person works at the University of Bonn, and that they are collaborating together through the internet, through their working relationships, because they're experts in different parts of this, to produce a paper on interstellar object 3i Atlas. And during the height of the observations, we were seeing a couple of papers a week coming out, sometimes a couple of papers a day coming out from different astronomers around the world who had either gotten access and were able to take images of 3i Atlas with their telescope, or were performing some kind of simulation based on their knowledge of comets in general. And so NASA had very little role in what happened with 3i Atlas, right? It was discovered by Atlas, which is a international collaboration. It's a all-sky survey telescope, has nothing to do with NASA. Then the following observations were done with the Vera Rubin telescope, with, like I said, James Webb, Subaru. None of these have anything to do with NASA. Now they can be partners and collaborators in various things, but NASA doesn't run them. So I think NASA did what it always did, which was that it 20 years ago funded and led the development of a telescope like James Webb or the Hubble Space Telescope that was one of the cast of characters that were used in the analysis of something that was interesting that was happening out there in the cosmos. And like the easiest way to know that people they've got this kind of shortened version and a distorted idea, really, of what NASA's role is. You look at the flat earthers and so on, they say, like, never a straight answer, right? NASA, like it is like blaming your high school principal because you feel like there's things on the television that aren't correct, right? And you're like, wait a minute. Man, I'm trying to take this analogy all the way to the end. So you're watching something on television, some news thing is happening on the television. You're like, I don't think that's real because Mr. Gibson in grade 8 was my principal, right? There is no connection. He has no relation. And he is not responsible for the news that you think is not real. And it's possible that the news is real. So why I'm kind of going to this diatribe is that it's like it's really important to understand that NASA is an infrastructure organization. They provide the tools that the astronomers use to analyze the things that they're seeing, and they're very hands off about this. We built a telescope. Go ahead and use it. Tell us what you find. So blaming the car manufacturer, I don't know how to come up with a good analogy. I'm sure somebody is gonna do this as well. So yeah. Michael McConnell, are you a fan of Warhammer 40K? So I used to work at Games Workshop. Games Workshop has a store in Vancouver, and when I was like 20 years old, I was super into Warhammer, and I knew the owner of the Warhammer shop, and so I was working there teaching people how to paint figures and running Warhammer 40K games with them and Warhammer Fantasy. So yes, I have written role-playing game supplements. Yes, I can out nerd you all. Gio Hondo, are there consequences for crashing a rocket in the ocean besides killing the local poor lobsters? I feel like the world should frown on this. I mean, there are obviously consequences, but it really depends on where the rocket crashes, what's on the rocket, and you have to put that into context with the other things that are happening on planet Earth. So when you have a rocket that is, like, say Starship, when Starship is landing in the Indian Ocean, in the middle of the Indian Ocean, it is thousands of meters deep, the water there. And so this thing is sinking down to the bottom of the ocean. Now it is going to release some fuel into the ocean wherever it crashes. But fuel is leaked into the ocean at all times. That I'm sure a small marina somewhere on the west coast of Canada, all of the combined ships are leaking fuel that is the same or more than what you get out of a Starship crashing into the ocean. That, if you're concerned about fuel leaks, boy, can we clean that up. Oil tankers that are heading off across the ocean, carrying millions of gallons of of oil. Like, just think about the terrible disasters that happen when these things crash. Even if they don't, I mean, things are leaking fuel into it. You can go out and look at the ocean, and you can sometimes see a sheen of oil on the ocean, that there's, there are pollutants in that ocean. So, always you have to put it in context with the other things that are happening. Are we concerned about rockets crashing into the ocean? If we're concerned about pollutants, there are easier, quicker, bigger levers that we can pull on. Are we concerned about metal going into the ocean? Not really. In fact, it appears that when, say, ships are sunk, these provide really interesting, useful habitats for sea life, that you get a restoration of sea life. And so a lot of the times they will take old ships, they will strip them, all of the toxic parts off of the ships, and then they'll sink them. And then you come back a couple of years later and the thing is covered by coral, and fish have returned, and there's, a lot of stuff that is going on. So I think you can balance that with a number of ships that are going into, and then the amount of garbage, the Great Pacific Garbage Patch, the amount of plastics that are just being dumped into the oceans by all of the world's rivers. Sorry. I tried to hold it off as long as I could. And so I think it's really important when we see these kinds of things and we feel very frustrated by events that are happening. We look at this rocket crashing into the ocean, exploding, sinking into the water, and like, that felt wasteful. That felt bad. But that instinct should then be matched to some other instinct that says, I am concerned about the state of the planet's health. I'm concerned about the pollution that humanity is causing to the planet. I should investigate and contribute and think about how I can participate, or at least draw a light to the things that are causing damage to our planet, because there are things that human beings are doing right now. Methane leaks, obviously, putting carbon emissions into the atmosphere, that are causing all kinds of short-term and long-term damage to the planet and to life and to humanity's stability in the kind of climate that we had become accustomed to. And so I think you have to put these things into context. Rockets definitely release carbon dioxide when they launch, but there are tens of thousands of airplanes flying every single day. And so the amount of carbon dioxide that rockets release is a fraction of a fraction of a fraction of a percent compared to ship traffic, car traffic, plane traffic, that if you're concerned about these kinds of things, there are a lot of things that we should do that would allow us to reduce our impact on planet Earth. And that should be your trigger to say, oh yeah, I care about this. Let me look into how I can encourage more transit in my city compared to people driving cars. Or I should vote for people who are looking to push more efficient fuel standards. Planet Earth there is 100 tons of debris from space raining down on planet Earth across the entire planet every single day. Just little bits of metal and rock coming from space, and it's just raining down on the planet, across the entire planet. That is the background. And a lot of those are like on your roof, which is very cool. But so it's just like super important to put these kinds of concerns into context for what is the larger damage that humanity is doing to the planet, or really how humanity is risking itself. I'm going to do some math here. Hold on one second. Come on, Wolfram Alpha. Escape velocity of the solar system at 3 AU. Let's see if we can do this. Nope. Okay. So I'm going to go with my default answer then. All right. Okay. Noon Loon. How fast would you need to be going by the asteroid belt to leave the solar system? So I'm not able to do the math right now instantaneously, but I can give you sort of a general way to think about this. The escape, what you're talking about is the escape velocity of the solar system, that there is a speed that you can go where if you exceed that speed, then you are leaving the solar system and you are never coming back. And we have sent 5 spacecraft on escape trajectories from the solar system: the Pioneers, the Voyagers, and New Horizons. And what that meant is that they are going so fast that they are not able to then fall back in to the solar system. And the escape velocity of the solar system depends on your distance from the sun. So if you're like right at the surface of the sun, I think it's like 42 kilometers per second. And then if you are on planet Earth and you are orbiting the sun and the Earth is giving you 30 kilometers per second, then you only need an additional 12, 13-ish kilometers per second. Let me get these numbers correct. Let me be absolutely sure. So from Earth, it's 42. Okay, yeah, all right. Let me do this again. Okay, it's much faster. All right, let me do this again. All right. So I'll use so Chad, take that part. Okay. Now the escape velocity from the sun is ludicrous. Like if you were sitting on the surface of the sun, it is hundreds of kilometers per second. Like you are not able to get that kind of velocity. But here at the Earth's orbit, it is only 42 kilometers per second. And the Earth is already orbiting the sun at 30 kilometers per second. So you only need to put an additional 12 kilometers per second on top of the speed of the Earth for you to be able to launch on a trajectory that's going to carry you out of the solar system. And that doesn't sound like a lot, but it is a lot, and it requires some tricks. Usually they'll use gravitational slingshots and assists. So they'll fly their spacecraft down into the gravity well of Jupiter, steal some of Jupiter's orbital momentum, and use that to slingshot them out into space. And the Voyagers were able to use Jupiter and Saturn, and Voyager 2 was able to use Uranus and Neptune to be able to complete its gravitational assists. So the velocity is about, from Earth, it's an additional 12 kilometers per second. And that is, as you are flying away from the Earth, as you are flying away from the sun, you are going to be slowing down. That you're sort of imagining that you're flying away from the sun. And as long as you don't hit zero at an infinite distance, then you will escape the sun's gravity. And if you go a little bit faster than that, then you're off into escape. If you're like a little less than that, like so you're only going 11 kilometers per second when you leave the Earth, then you will fly really far away, and then you will fall back down into the sun. And so as you are moving through the asteroid belt, which is farther away from the Earth than the sun, you will be going some fraction of that 12 kilometers per second. And as long as it is fast enough, like I think it's like 27 kilometers per second. So at Earth, you need to be going 42 kilometers per second. And at the asteroid belt, you need to be going 27 kilometers per second. And I think like once you're out to Neptune, it's less for you to be able to pass through. And you're just going to be constantly slowing down. You just need to make sure that you don't hit zero at infinity. Oh, and you asked, and how do you stop? Oh, and you asked, how do you stop? Well, that's a totally separate question. And this is this comes down to the flight paths that that scientists consider, engineers consider when they are developing missions. We think about New Horizons, which NASA was able to send to Pluto. It took 10 years that they launched it, did a flyby of Jupiter. It picked up more velocity. It was able to make a flyby of New Horizons, but it was not a slow flyby. It came in fast, took a bunch of pictures a couple of days before, took a bunch of pictures up to a couple of days after, and then it was back out in deep space again. And that's because they went fast. If you actually want to go into orbit, if you want to stop, then you've got to go in a totally different orbit that takes longer. If you just want to do a flyby of Mars, you can get there faster. If you actually want to go into orbit around Mars, you have to take a trajectory that gets you to Mars so that then you can fire your rocket engines and you can go into orbit around Mars. And that actually requires a longer journey because you're going slower. You're just going just fast enough to get to Mars, but not so fast that you fly right past. Luke Skydropper, do not believe everything you see. Yeah, that is great advice. And that is why we have developed the scientific method. And that's why we have developed scientific experiments and instruments. Think about infrared. Your eyes perceive a very narrow bandwidth of the electromagnetic spectrum. You can see red light through the rainbow up to violet. But we know that that is just a tiny little portion of the entire electromagnetic spectrum. You can't see radio waves. You can't see microwaves. You can't see infrared waves with your eyes. You can start to feel infrared with your hands, right? You feel the heat. That is infrared radiation. We can't see ultraviolet, but I guess, a sunburn is an ultraviolet detector so your skin can see ultraviolet by taking damage. We can't see X-rays, although X-rays can see through us, and we can't see gamma radiation. We can only see what we can see. And so a long time ago, scientists realized that there were things that were too small for us to be able to see, things that were too big for us to be able to see, things that were too far for us to be able to see with our own eyeballs, and things that were shifted. We can't see magnetism. We can't see gravity. That there are all these things that we can't see. And that once we develop the tools that allow us to start to see these things, it gives us a much better sense of the universe that we find ourselves in. James Webb is a great example. But actually, when you think about infrared, think about an infrared camera, right? I don't know if you've ever used an infrared camera. I mean, you can buy them on eBay or buy them on Amazon. They're really cool, because they convert the infrared radiation, essentially the different kinds of warmth that are coming off your body, and they just convert them into colors that we can see. So suddenly you can see that your face is hot, that your shirt is cooler, that if you put on something that is very cold, it gets a lot darker, more towards the blue. And it is not that lower temperature or a longer wavelength infrared is blue. It is that the camera system is converting the infrared that you can't see into the colors that you can see. A microscope is showing you what you couldn't see previously. It is magnifying, but that thing is there. And so I think, we have seismometers for us to be able to measure the movements of what's going on inside the earth. We have ways of measuring air pressure. We have ways of measuring so many of the things that are going on around us. And these things are real. They just weren't accessible to the senses that we have available to us. And by not demanding that the senses that we have be true, and instead starting to accept and rely upon this greater suite of senses, this kind of augmented human with, human plus microscope, can see more than just a human being. And so once we learned to take advantage of these other ways of seeing, we made a lot more progress in our understanding of the cosmos. Now, I know that's not what you were saying, but that's the answer that I wanted to give. Owen Bowen is saying, moderator, surely you can see New Loon cult is an AI. I don't care. I'm not an AI. Therefore, I can look at the questions that people are asking and decide, is that a question that I want to answer? Is that a question that I think will be helpful to other people? Is a person asking like a flood of questions? Are they just super enthusiastic, or are they an AI? It doesn't really matter to me, because I am able to filter them in real time and decide which questions I want to answer. So don't worry. If New Loon is saying nasty things that would get them banned, that's a different story. But that's not what's happening. They're just flooding the comments. So totally fine. Yeah, don't worry about it. Don't worry about it. It's fine. Blackberry saying, must be funny to be accused of being AI. Man, like, people accuse me of being AI. Like, we are now in this world where nobody knows what anything is real or whatever, right? I think we've all gotten super good in the last couple of years to be able to detect all of the tells of AI. That it went from 0 to really good, but then stopped getting perfect. And so there's still this uncanny valley. I don't know if you're experiencing this, but I've been watching television shows. And what was the one that I watched recently? Paradise. Yeah, Paradise. Season 2 of Paradise. And I was just going, AI. There's these little witty, snippy, snappy conversations that people are having where someone is saying this and like, it's not this, it's that. And they're just like AI-isms galore. And it was excruciating to listen to, because that the writers were just like, oh, this scene needs some kind of way of warming up to each other. Let's just get it. Let's have the AI. Oh, that's good. Let's just go with that. And yeah, it sucks. And I think we're sort of at the other side of this, where people are angry about the AI. People are worried about the AI. And we're kind of finally starting to put it into its proper location, right? Like, if you write me an email with AI, I'm not going to read it, right? I don't want to read an email that you didn't write. And most of them are marketing messages from companies. Hey, Fraser, I really enjoyed your recent video on answering questions about space. And going into detail, and I'm just like, delete, because you didn't take the time. You literally just didn't take the time to make a human connection. Get lost. So, and I think that we're at this place now, and apparently Google now is putting an AI flag on videos that are made with AI, if it can catch it, if it can detect it. And that's great, because then you can just go, like, don't ever show me anything made by AI. And you will filter all of that out of your feed. And then the people who made a quick buck making stuff with AI will realize, oh, there's no money to be made making stuff with AI because nobody wants to watch it. Therefore, I will stop doing that. And we should get back to some kind of new normal, until the AI is either good and it's worth watching, worth listening to, worth reading, or it's so good we can't tell. We're not there yet. Jeff Hans, do you think future people will look back on us with pity for only having natural vision and hearing for our entire lives? Yeah, when you sort of read Blade Runner, no, when you read, oh my God, William Gibson, Cyberpunk, not Johnny Mnemonic, Neuromancer. When you read Neuromancer, when you think about Cyberpunk 2077, when you look at people who are enhanced in all of these different ways, part of me is like, yuck. Dude, like, keep that bone saw away from me. But part of me was like, man, if I could swap out my eyes with something that would allow me to see farther across the electromagnetic spectrum, that would be super cool. And so will we have this future where these things are provided inexpensively so that you can see across the electromagnetic spectrum, hear distances, see with microscopic vision, telescopic vision, that would be pretty tempting. Yeah. Brenda Fry, when a planet is gobbled up by a black hole, would the planetary magnetic field be measurable as it is destroyed? Sort of. So, black holes, once something becomes black hole, there are only three ways that you can measure a black hole. You can measure its mass, the total amount of stuff that has gone into the black hole, the total amount of energy, the total amount of dark matter, total amount of antimatter, it all turned into black hole. That becomes the mass. That is one number. The second number is the spin. How is this thing rotating? And black holes, as they turn, will actually tangle up space-time around them. And you can measure that tangling of space-time as these things are spinning, and you can measure that rotation rate. Generally, black holes are spinning as fast as they can, as fast as is permitted by the by relativity, right? By general relativity, that there is this maximum speed that you just can't kind of push a black hole to spin faster and faster than that. But theoretically, you could take a black hole and you could feed it material that was going in the opposite direction of its spin, and you could slow a black hole back down until it stops. So you can kind of manipulate the spin of a black hole. And then the last thing that you can measure is the charge, the magnetic charge of a black hole. And once again, like this mass, like the spin, the magnetic charge is the sum of all of the electromagnetic charges that have gone into the black hole. So if you only fed a black hole electrons, then it would be negatively charged, and it would be significantly negatively charged, and it would be attracted to positive charges. That if there was things that were nearby that were the opposite charge, then the black hole would literally move towards them, or those things would move towards the black hole, in addition to the gravity. But the thing is that electromagnetic charges can be positive and negative, and so over the sort of larger scale, they tend to even out and average out. And so while a black hole does have the charge, the sum charge of all the stuff that went into it, is generally balanced. And so you're asking, would you be able to measure the planetary magnetic field? So the planetary magnetic field, all the particles that are in the magnetic field, the magnetism of the dynamo at the center of the planet has a charge, and that will be added to the black hole. And the black hole will get the mass of the planet. The black hole will get the spin imparted by the material that it adds from the planet, and the black hole will get the charge that came from the average charge that came from that entire planet, and that will add or subtract to its existing ledger. And that will add or subtract to its existing ledger. You definitely need to settle down, New Loon, though. Starting to border on spamming. Michael McConnell, so who's your favorite faction and why is it the Orcs? My favorite faction are the Orcs. Why is it the Orcs? Because the Orcs are the best. And red goes faster. Technophile, if China is serious about going to the moon on a continuing basis, how, if anything, do you think that will give them an advantage in determining the future of humanity? So I do think that China is serious on going to the moon on a continuing basis, that, by 2030, they're hoping to land some humans on the moon, that we will then see follow-on missions to the moon, that we will see some kind of permanent inhabited station on the moon. Hopefully, I would love to see an international collaboration of many nations, not just the Chinese, but I wouldn't be surprised if we end up with a Chinese station and a not Chinese station, maybe a Europe U.S. collaboration, or like who knows how bad international relations will have gotten by 2030. So it's all up for grabs at this point. But what China gets out of sending humans to the moon is they are able to brag about their technological capability in the exact same way that the Americans and the Soviets were racing for back in the 60s and the 70s, which was the first nation to be able to land humans on the moon. It can brag about its technological competence. And it ended up being the Soviets blew up their rocket. The Americans landed humans on the moon. They were in a race though. And now the Americans have rightfully got the bragging rights to say, we put our minds to it. We did this and all of the other things, not because they were easy, but because they were hard. And that the nation dedicated itself to this incredible goal, and they pulled it off, and they spent the money and they achieved it. And then they realized it was too expensive. We don't need to do it again for a while. That is what China wants to do. China wants to show that they are not the place where you buy cheap crap at scale. They are a world leader in new technology. You know, like this is not me sort of parroting their perspective. I'm saying like this is what China is hoping you will take from this, in them having some kind of continued presence on the moon. That when you're in the store and you're looking at drones and you're like, do I buy the American drone or do I buy the Chinese drone? Well, the Chinese have a base on the moon, so I'm going to buy the Chinese drone. Ooh, do I want to buy the American electric bike, or do I want to buy the European electric bike, or do I want to buy the Chinese electric bike? Well, the Chinese have a base on the moon right now, so I'm going to buy the Chinese electric bike because they seem to know a lot about electric bikes. And in fact, this electric bike is used by the astronauts on the moon. That's the goal. There is no military advantage. There is no technological advantage. There is no power to be gained by putting humans on the moon. It is 400,000 kilometers away. It is nothing. It is very far away and completely insignificant. It is not a base of operations to dominate pathetic humans. It is just a flex, and it's a branding operation. And then you can decide, is that impressive to you? As more and more of the technology that you use came from China, and if your perspective of China grows and grows, and instead of it being this place where crap gets made to, man, all the best stuff comes from China, then they will be, and then the bases on the moon will be part of that story, that narrative that they are hoping you will adopt, their brand. I'm Starshine. You look very healthy, Fraser. I'm still jet lagged. Oh my God. You can see the bags under my eyes. Maybe my lighting is too good. Jet lag is the worst. Every time you think you can power through it. No problem. 8-hour shift. It's easy. I can do this. I'll just stay up and then I'll just go to sleep and then I'll wake up and then I'll be through it. No, it's going to take a week. Day after day, 1 hour per day, as you make your way through it. Jet lag is brutal. Jimmy James, I'm here for the rants. Well, you got to give me the rants then. You got to encourage the rants. I don't know what the rants are going to be. They're in there somewhere, and we don't know until somebody summons the rant, and then the rant arrives. The rants are my favorite part too. I have to walk that fine line between ranting about something without being an asshole. Right? That's the challenge, is to rant in a way that people watch it and go, yeah, you're all right, Fraser. Right? That's the goal. as opposed to me taking cheap shots and so on, because it's not my style. So it requires the perfect topics for me to be able to rant on them. But I'm glad you're enjoying the rants today. Paige Potter, what do you think future historians will misunderstand most about the people who first expanded humanity into space? So first, Paige, keep tuned for the QA this week. The Thursday QA, which is coming out in 3 days, is just your question. The whole thing is me answering your question about how I've changed my mind. And it was a 15-minute answer. Talk about rants. And Anton, not that Anton, thought that it would be cool to just make that the entire episode. So that's all on you. This time, Paige Potter, what do you think future historians will misunderstand most about the people who first expanded humanity into space? I know I'm reading the question twice, but just to get it in my brain again. I mean, when we think about history, the misunderstandings come fast and furious, you know? Look at the arguments about Christopher Columbus, about the early explorers into the Americas, the early interactions between the West and the East when the first ships reached Japan and China and so on. When you think about the personalities of Rome or the Peloponnesian War, the kinds of things that we know, like history has very bad memory. And it really takes archaeologists and historians a lot of very careful effort to put it all back together again. And so it may very well be that the documents and the records that we have today will stand the test of time for future generations, and they'll be able to go and watch exactly all of the events unfold as they actually happened, which is what I think our default expectation is going to be. But the reality, of course, is that there are machines, and you're living in this right now, where there are people that are attempting to shape the narrative on the things that are happening right now, that there are people who disagree about COVID, about vaccines, about climate change, about all of, just so many things right now. And that's just happening in real time. Like imagine if you could look back at those controversies 100 years from now. It's going to be a mess. So I think that the future, like just history in general, people looking back to the early days of space exploration, that they will probably think that it went very easy, right? That they'll it was 1954 and we saw Sputnik. Then 61, we saw Gagarin. Then 69, we saw the first people on the moon. Boom, boom, boom. Then we saw the space shuttle. Then we saw the Space Launch System. Then people returned to the moon. And here we are now on our way out to Alpha Centauri. It all just happened in a blink of an eye. And I think from our perspective as the people that are going through this, living through the time, it feels agonizingly slow. It just feels like it's taking forever for us to get on with the exploration of space. And I think that's pretty funny, that so when you think back and then you sort of apply that framework to the sorts of events that unfolded as people were living through World War II, as people were living through the 30 years war, right? Just the grinding day after day after day of these momentous events. That's what I think is the misunderstanding, is that people in the future will look back and go, wow, people must have just been shocked about how quickly that all happened. And yet if you actually talked to us, we would be like, oh, it was so slow and so frustrating and so boring. I think that would be a pretty big part. Mimi Virus, will Europe ever get to the level of the American and Chinese space industry? So Europe has the European Space Agency. Excuse me. Europe has the European Space Agency, and while their budget is not as big as NASA's, it's pretty big. It's about like 60 to 70% of NASA's budget. And they fund the training of astronauts. They build modules for the International Space Station. They develop the Ariane rocket system, and they have a ton of missions. Gaia, the Gaia mission, the Plato mission, the Ariel mission, the upcoming Comet Interceptor mission. Like, there's a ton of missions that are being done by the European Space Agency. The Rosetta mission, like, it goes on. And so they actually get a lot done. And then the Chinese, I think, are about 50% of the budget of NASA. And then, of course, there's the Indian Space Agency, which punches way up above their weight. Very, very cool space agency. There's the Japanese Space Agency. And then there's smaller space agencies. The Canadian Space Agency. I think UAE has a space agency. So there are a bunch. And so, like, will they ever get to the level? Well, I mean, it really just depends on how much money they're willing to spend. And I know money is pretty tight in Europe, so they're not willing to really spend a lot of money right now. The Russian Space Agency, although that's sort of in tatters right now. But yeah, so will they ever get to the level? I don't think Europe sees itself as a competitor to NASA or the Chinese. Oh, I might have to cut this a little early. Let's see. I don't think that Europe sees itself in a competitive race with the Americans and the Chinese. They have a certain population, they have a certain budget, they're rolling that budget out for the scientific questions that they want to have answered, and they participate in the space flight opportunities that they have available to them. The European Space Agency has collaborated with the Chinese Space Agency. There's a mission that they've worked on, the Einstein probe. So there's a lot of this collaboration between Europe and the other space agencies. Church discography. What bit of knowledge are humans most likely to ask of an advanced alien race? And what knowledge are they most likely to provide first? I mean, we tackled this question a couple of weeks ago pretty extensively. And the thing that I think, we always need to be really careful about is information hazards. That if we are communicating with an advanced civilization, they may not have our best interests in mind. And so they might be sending us a bad idea. And the example I always use is Contact. In the movie Contact and in the book, they detect this signal coming from space, and then it turns out it's instructions, a blueprint for building a machine, and then they build the machine. And what do you know? It's a wormhole that allows you to transport around around the universe. But it could also be a machine that makes a black hole that consumes the Earth and then takes humanity out of the picture. Think of a pluribus, right? A message is received. People just can't help themselves. They have to make what the message tells them, and things turn out badly. So I think we would have to be super careful about even listening to any signal that we get from aliens, not to mention building anything they recommend. And so, we will have bits of knowledge that we will want answered. Absolutely. We would want some kind of comparison. We would want to know, here is what we consider to be science. What is the science that you guys have done? And I loved in Project Hail Mary, if you read Project Hail Mary or watch the movie, the Rockies species, Epsilon Eridani, the Epsilon Eridanians, they are great at materials, and yet they didn't know about relativity, and they didn't know about physics. And so they were able to make a spacecraft, but they didn't understand how long it was going to take for them to get to Tau Ceti. And they didn't understand some of the consequences of it. And so you can imagine a civilization goes down a very specific rabbit hole of science and technology, gets really, really good at it. If you read Children of Time by Adrian Tchaikovsky, there are these advanced spiders, and they're very good at certain kinds of technology, and it's kind of amazing, and how the humans are interacting with these spiders, and they're both good at different things. And so I think that would be the question, was just like, how are you different from us? What do you know? You know, do you know how stars work? Yes, we know how stars work. Okay, do you know what dark matter is? Right? Oh, yeah, we know. What? Okay, tell us. Right? And so there'll be that back and forth of just finding out what are all the gaps, what are all the differences in your knowledge of the universe that you can then be able to come back around and then start to share. Because it, like, imagine you went back in time and you got a chance to sit down with someone like Newton or Galileo, and you are a space nerd. You're watching the you watch a lot of our videos, so you're very familiar with concepts in space and astronomy. And you sit down with Galileo, and Galileo has a bunch of questions for you. Like what? How does the sun work? You're like, well, I don't really understand, but hydrogen is being turned into helium at the core, and then that releases energy. That's fusion. And he's like, oh, okay, right? Oh, what's on Venus? What's on Mars? What are these ears that I see on Saturn? Oh, those are rings. That you would fill in all of these bits and pieces of his knowledge about the cosmos, that he had a hints of it, and now he'd be able to get a much better understanding. I'm sure he would talk your ear off asking questions, because he would be so curious about this stuff that you had concrete answers for him. And that's what I feel like it would be like with the advanced civilization. The aliens show up and we'd be like, here's what we know. Tell us what you know. And then we've got a bunch of questions, and you're going to have a bunch of questions, and let's figure out what we don't know that the other person has already figured out. And that will make, we would 50% our knowledge overnight, just by getting a chance to chat with another civilization that independently uncovered the secrets of the cosmos without influence from our biology, our history, our culture, our personality. That would be amazing. Owen Bowen, have you any comments on the UAP documents and videos that are being released? Yeah, and it is all underwhelming. None of it is useful or interesting or anything that scientists can make any progress on. And so it is, once again, we are waiting for somebody to actually deliver data, anything useful that anyone can make any progress on. And so the name unidentified must remain from this point forward. Now, some of the things that were released, people quickly identified them. Balloons, the usual suspects, right? Balloons, airplanes, birds, infrared sensors. Other stuff remained unidentified. It's right there in the name, unidentified. So we got to wait. I cannot wait. I'm so excited for positive proof that aliens are visiting Earth. That would be the greatest discovery in the history of humanity, and I am for it. But I want to know for sure. I don't want to guess. I don't want to speculate. I don't want to be and then turn out to be wrong. I would rather just wait, remain unconvinced until proper evidence shows up. So I found this most recent batch deeply disappointing, and like, I know a lot of people are really excited. Like someone is, information is coming out, but where is the ship? Where are the bodies? Where are the weird metamaterials that scientists can examine under the microscope and learn and make discoveries and come to new conclusions about what it is that we're seeing, as opposed to blurry things moving into distance at the very limits of what our cameras can detect. Again. Technophile, silly YouTube, I'm sure you're aware, but they have begun the unavoidable pop-up ads on your channel. Okay. Can you describe this for me? Because that sucks. Where are they popping up? because we turn off. So we have not. So right now, so I'm looking at my YouTube control, and it's saying insert ad. I've never done this before, but I'm going to do this now so that you can experience it and see if that is different from what it is that you're experiencing. Okay. So like, I am never going to do this again. Like, I'm never going to do this on purpose, but I'm never going to do this to make money. I'm going to do this so that you can experience what an ad is like when I put it into the stream and see if that's different from what it is that you normally experience. Okay, so you're all ready. Okay, here it comes. I just pooped an ad. So tell me what happened. Do I have to wait? Do I have to stop talking? Is the ad going to show up on your screen? Is the ad going to show up on the side? Does it cover the screen and does it make you skip? So nothing so far. Weird. Okay. Well, if you've got an ad blocker, then you won't see them. But I would love to know. Okay. So now on my screen it says okay, people using premium, so good. Okay, so you skipped. So there was a video ad. You skipped after 5 seconds. So it was full screen. Okay, all right. So that is a thing that I will never do. I will never do that again. We did that as an experiment. I'm never going to do that again, but you experienced what YouTube wants me to do, and I will not do it. The next thing is turn on automated ads to temporarily pause mid-roll ads for viewers who send gifts, super chats, and stickers. So, and I'm not going to turn that on. So in other words, if you send me super chats and stickers, then you won't see mid-roll ads. So does that mean that you're seeing mid-roll ads? I mean, I've been expecting this day to come, but let me check. Let me edit. No, I don't think I can. Analytics, stream health. There's no mention of advertisements. Monetization. So I've got the ad automator turned off. And the mid-roll. Okay, good. So I've set the mid-roll ads as manual. And since I never click the mid-roll ad, they never show up. So that's good. But there is an ad. And so if you're not a premium subscriber, you're seeing an ad that is going over top of the chat. That's gross. It makes me so mad. Like, obviously this is a slippery slope that they give me the control to not put in mid-roll ads, which is great because mid-roll ads suck. And can you imagine if we just did I'm doing a 2-hour video, I could put 5 minutes of ads every hour, half hour. That would suck. But it's just like, we're just on a countdown before they make the mid-roll ads happen automatically. Christian DeSalier, just use ad blockers. I mean, so the problem with an ad blocker is it is violating the terms of service of YouTube, right? That you, and that it is, I mean, there's a bunch of reasons. There's problems with it. I'm funded by Patreon. And so I don't care about revenue from YouTube. And so I'm free to turn it off. But there are other people who are funded by YouTube, and that if enough people block their ads, then they can no longer do their YouTube. And so if you're like watching a YouTuber and then some beloved YouTuber can no longer make videos, you may want to say, did I do that? Did I block their ads and now I'm no longer, and because they couldn't afford to do this job anymore? Like, it's razor thin for a lot of YouTubers out there. So I don't think that using an ad blocker is the right thing. Like, YouTube Premium is, what is it, $15? And it gives you unlimited YouTube videos, no ads. You get tons of other features as well. If you were to strip away all the streaming services that I use, YouTube Premium would be the last one. Like, I cannot suffer a single ad, and $15 is, for me, worth it to spend to be able to get this thing that I watch way too much every day, to be able to watch. And so I think you just have to say, do you care about the YouTubers that you watch? You don't have to worry about me and my team because we are funded by Patreon, thanks to everybody. And so if YouTube gave me a button that I could turn off all of the ads on YouTube tomorrow, I would press that button. But they won't give me that button. They are taking these buttons away from me bit by bit by bit. And so I don't have that control. But if I did, I would. But there's lots of other YouTubers that this is their income. This is their job. And so you have to balance that, where you're watching their stuff and you're stripping out the ads, and that's their living. And you know, I'm not going to make a judgment about that, but you're going to have to sort of find where you sit with that. And for some people, it's fine. Who cares, right? If you're going to watch CNN, I'm sure it's fine. If you're going to watch some small YouTuber that's just scraping by and is putting all of their heart and soul into the videos that they're making, and they're just barely able to pull it together, you should decide whether using an ad blocker is the right move. And the way you resolve this is you just get YouTube Premium. It's $15, and you can download videos and play them offline on your phone. You can listen to videos with your screen off. I do this all the time. You can go faster speeds than you normally can just with the regular YouTube, and you don't get any ads. And the creators get a lot more money from YouTube Premium than they do from ads on their videos. Like, if everybody switched to YouTube Premium, YouTube could dramatically decrease the cost of YouTube Premium, and nobody would ever have to see an ad on YouTube ever again. So you just need to decide where you fall on that spectrum. And if you do use ad blockers, then the very least you can do is, like, specifically identify the creators that you love, and especially the ones that you know are having that you know, they're not living in a mansion, you know, making a fortune, that it is a labor of love and that they are doing a really good job. And then either just super chat them or give them a super thanks or whatever is give them a super duper money cash happy love donation, or just get YouTube Premium. Like, if you love YouTube, just get YouTube Premium. If you watch a lot of YouTube, just get YouTube Premium. And then you don't have to play this cat and mouse game with ad blockers. All right, that's the rant is over, right? But, like, YouTube Premium over Netflix, YouTube Premium over Prime Video, YouTube Premium over Disney, over all of that stuff. It is, come on, we watch a lot of YouTube. So that's the streaming service that we love the most. Where are we at? 57. I think we've reached the end of the episode. So there you go. We got another sort of partial rant at the end there. And I think my voice is definitely starting to go. So I'm going to wrap things up. Thank you, everyone, who hung out with me on my triumphant return, after being gone for 2 weeks. It's always super fun. Remember to prepare yourself emotionally and physically and spiritually for the fact that I will be on hiatus in 4 weeks from now. But we'll enjoy this time while it lasts. Thanks, everyone. Thanks in advance to Chad and Anton, who have to edit this nonsense. Thanks to everyone who asked the questions. Thanks to the moderators who hung out and kept things safe. I really appreciate all of the questions, and we will see all of you next week. Thanks, everyone.